So before we started our off-grid solar build, I had zero electrical experience.
We now have a fully working off-grid solar setup that runs our camper, and it really wasn't as hard as we anticipated. It's easy to get intimidated by the details. How do I strip and crimp a wire? What size wire do I even need?
All this stuff really just served to distract me and intimidate me about starting the project because I didn't really understand the why to each system.
I stopped thinking about solar as wiring and started thinking about it as 4 simple systems that I needed to understand. First, I needed a way to generate power. That was going to be my solar panels. How do I turn sunlight into electricity? The next component is I need a way to store that power so energy is available when the sun isn't. Then I need a way to control the power. I need a control system, a brain that decides where the power goes and when I need that power. And finally, I need a way to use the power, to actually plug an outlet into normal household circuits and outlets.
So once I understood it as 4 separate components with distinct jobs within a system, it became a lot less intimidating and I felt like I was ready to get started. Okay guys, so I do want to make a disclaimer here. I'm not an electrician. I'm not the person to come to for advice on circuits and everything else, but I do want to show you how with zero experience, I was able to get my camper working full-time off-grid using this solar system.
To start the whole project off, our system diagram suggested we wire our panels in series.
So series just means that each panel connects directly into the one next to it. It creates a single high voltage pathway. Each panel adds voltages as you go when you're using a series system. So as each panel connects negative to positive, eventually you're going to end up with one negative left over and one positive left over. Those are going to connect into your PV extension lines. From here, it's going to go over to your solar system. Now, series was a simple decision for me because series has higher voltage, which does better across long distances. And I'm going to run these about 20 feet into my solar shed. Now, we do grounding very similar to the way that we're connecting the wires. We're going to make sure that the ground wire is connected to each individual panel, and then we're going to route this back with my PV lines to my solar shed for grounding later in this video. Now, for me, I actually didn't want to leave all my connections together because I needed to go finish the rest of the components in my system. So once I had it all staged, I actually went ahead and disconnected everything so they were all standalone. I wouldn't create any high voltage currents. But that brings up a great question. Once we get the power generating, where are we going to store that power for use later? For a power storage system, we're using a battery server rack. Now, these batteries are wired in parallel. Parallel allows the batteries to act as one large battery system rather than individual batteries. Individual batteries wired in series would drain one at a time sequentially, which is bad for the life of the battery. So we want them to all act as one. So in parallel, each battery hooks up to a bus bar. We've got a positive bus bar and a negative bus bar. This is helping us keep the voltage consistent as we fill out the rest of our server rack. Now, to help my batteries in this parallel system charge and discharge a little bit more equally, rather than just pulling my power from the top of my bus bars, I've got my negative main coming from here and my positive main coming from down here. That's going to create a cross-flow system so that each battery discharges and charges equally. Now that we've got power being generated from the sun, we've got power being stored in batteries, we need some kind of system to tell all this power what to do and where to go. And that's our next step. The inverter is the brains of our system. This is what all of our power is going to be routed through. It's going to control that power and make decisions on what to do with it.
Generated power from our solar panels are routed through a PV breaker and then into our inverter. The inverter then decides to store that power or use it immediately. Our batteries are connected the exact same way with a few different fittings, and the inverter will decide whether it's time to use the batteries or charge the batteries.
So now that we're making decisions with our power, we actually need to be able to use it, and that's going to be our AC output into our circuit breaker panel. Now, the circuit breaker panel is just a distribution box. Power is going to come into it and power is going to come out of it.
Inside the panel are 2 bus bars, each carrying 120 volts. Together, they provide the split phase power needed for 240 volt loads. The inverter feeds both bus bars through a single 50 amp breaker, energizing the entire panel. Once the panel is live, individual circuits can pull power from it safely and independently.
The most important outlet for me to hook up was this 50 amp RV outlet, and it was extremely easy to hook up. And at this point here, I could technically start running my RV off of it, but there's a very important system we haven't discussed that we mentioned earlier, and that is the grounding system, a way for us to take care of problems when things go wrong. Every electrical system needs a grounding strategy. Grounding is less about making things work and more about making sure that all that power has somewhere to go safely if something goes wrong.
All grounding paths from every system, solar, inverter, batteries, they all return to the breaker panel and then connect to a single grounding rod driven into the earth. This gives stray current, static, and surge energy a safe path to dissipate.
Now with the system put together, there are a final couple steps that we glossed over here, things that you can set up extremely easily. One of them is your LAN cable that's going to connect your batteries to your inverter so that it can communicate well. Another one is your Wi-Fi port so that you can get on to your solar from your phone. And then the most difficult one is probably this little guy here where you're actually putting the settings together. Now, SunGold just got on the phone with me. I told them what elements I had to my system, and they told me what to put my settings to. So very easy process. But once you figure out this final minutia, you're finally ready to be 100% on power off grid. So this system is 100% working now, and my family has actually been living on this system off grid for the last 3 months in some very cold weather, which can sometimes be difficult for the batteries. Now, when it comes to putting the whole system together, I'm gonna say again, I had zero experience, but I took the time to do my research and understand each individual component. And if I can do that, I bet you probably can too.
This video is the big picture for us. What made it manageable wasn't skill, it was taking the time to understand what each part of the system was supposed to do. If there's a specific part you want me to break down, panels, batteries, inverter setup, drop it in the comments and I'll make those videos. Also, drop it in the comments if I need to improve something I've done here or if I've done something wrong. I am not an expert, I am not an electrician. I really hope that this helped some of you guys if y'all are teetering on the edge of deciding, should I go off grid? Can I do this? My opinion is you can definitely do it. For me and my family, we don't really know what we're doing, but we're just gonna do it anyway.